WebSocket? Yeah, testing WebSockets. Wait, it's on the course website. We're doing testing. No slides today. It's live coding. So let's do testing of WebSockets. This is one of them lectures. I guess it's kind of new this semester. I would always just fit this in wherever I had some extra time. I'd do a little bit of this stuff. And then office hours with WebSockets are packed because everybody's making the same mistakes. So I want to get those mistakes out there, show you how to avoid those mistakes, show you what to do when you run into those mistakes, and just give you general testing tips to help you out. Much like the testing multi-part last week, same thing, bless you. There are always tons of multi-part parsing questions, so I want to give you some tips and tricks on how to not run into those issues. Yeah?
I have a question specifically about the multi-part parsing. So when you get the content, I think it's content disposition or something like that, is the first index guaranteed to be form data? Because in almost all the slides you have, it is form data.
And it's always been form data in what I've seen. I don't think it's in general always the case because maybe it is. I don't know. I don't have a solid answer for you, but my guess is if there's something other than an HTML form that's using the multi-part format, that maybe that would be something different, but I've always seen it as form data.
For our purposes, we can just assume.
You can assume it, yeah. I mean, for our purposes, you only have one part, and you know it's going to be an image. So there's a lot you can assume. What was that?
Like in the actual content disposition, there's a lot of things possibly separated by a semicolon, right?
Mm-hmm.
Do you think it's guaranteed that the form data will always be the first index if we get the split?
I don't know if it's guaranteed in general, but I've always seen it as the first thing. All right. Testing WebSockets. And the first thing, something I wanted to at least mention, maybe I did mention off the cuff, but I don't think I highlighted it enough. So the very first thing I want to talk about is we are now at a stage where we have WebSocket connections, which is, by definition, leaving a TCP connection open for each client. So if I have one client, they send a request, an upgrade request for leaving that TCP connection open. Your server is going to leave that TCP connection open with this client and sit there on the receive method. And that receive method is going to wait for there to actually be data sent over the TCP socket, and then it'll return with the value. So your code sits on receive and hangs. What happens when user number 2 sends you a request? Your server is sitting here on receive with user number 1. What happens when I get this request? You've seen this in enough classes, so you should know the answer, right? We need concurrency. We need to be able to do two things at one time, or else second user doesn't get their request served. It doesn't get handled at all. Luckily, the punchline is going to be it's super easy to do, just the way that we've structured things so far. But I want to talk about what this problem is. So you're going to have your server. It's going to have a handle method, something like this, and you're going to have some code that looks like this. It's going to say, it's going to get the request. It's going to send back a response. It's going to say, obviously, that's what we've done since day one. It's going to get an upgrade request. It's going to send the response, the handshake response for the WebSockets, and leave that connection open. Whenever we hit the end of this handle method, that TCP connection is closed by our server. And if the client wants to send another request, they have to start a new TCP connection. So each HTTP request, the way we have our server set up, is a new TCP connection, TCP connection, request, response, close connection, new TCP connection, request, response. And if multiple users are using our app, that's fine. Our server, our library we're using is going to queue up their TCP connections, and we're going to handle one connection at a time, and that's it. Now with WebSockets, we send the response, the handshake response, and then we're going to have something like this. Well, true. And then we're going to receive data again. We're going to hang on receive. Ooh, wrong language. Expect receive data to be WebSocket frames. So you send the response, and you enter a well true And then if your received data, you're going to expect it to be WebSocket frames. We're going to parse those the way that we did in lecture on Monday. And if opcode equals 8, I'm mixing languages here. I almost did an open brace. Break. And that's the way you're exiting the loop, is if your opcode is 81000, that's when you're going to break out of this loop and then close the connection after that. Make sure you are breaking out of the loop and closing the connection on an opcode of 8, or else you're going to have receive returning 0 bytes, and that's going to break all your parsing code. Your parsing code is going to get index out of bounds error on index 0. That's because the client closed the connection, but you didn't update your connection. Or the client closed the connection for any other reason that's not graceful. Maybe it didn't like the frame you sent it, and it said, I'm done with this connection, and peaced out. Then the next iteration of your loop, you're going to index out of bounds errors. A lot of ways you can see that. Yeah.
You're doing if length of the receive that is 0, then you're returning nothing. Do you recommend doing that instead of well? Or no?
I mean, you can. I don't like doing this. I don't know why I have it in my code here. I'm going to leave it in just in case that has some impact on the lecture example. You can. I'll leave that up to you, though.
So that wouldn't change anything if it's out of it? That's what I'm asking.
If this, it shouldn't. I'm kind of mad at myself that I even have this here. The reason you would get received data of 0 is if the client doesn't, kind of what I was saying, the client doesn't like something you're doing, and it closes the connection without us, expecting that, which shouldn't really happen. Received data here shouldn't be length 0 because they just open the connection. This is the first thing that happens when a TCP connection is open. So for a client to open a connection, then close the connection, really shouldn't happen. It does happen from time to time, and I haven't been able to pin down the exact reasons, the exact situation. So I don't have a better answer, but I like having this here. You know what? I am going to remove it just because it shouldn't have to be there. But this is what we're going to have in our code. I'm not going to implement the whole thing. We actually do have WebSockets somewhere else, but in a file that I have to be careful going through. But this is roughly what you're going to have. Request, response, that's the WebSocket handshake, and then you hit the well true. So let's run this server. Get a request. We get a request. That kind of ruined my example. The fact that I got errors helped me. I should just get the HTML if this works the way I think it should work. Okay, so we get a request for the root path. We're going to respond with the HTML, and even the HTML didn't load. Let's inspect the element and see what happened here. Let's stop my server. Yeah, we did get the HTML, but it didn't render anything. So we're going to get the HTML, and then everything else is pending, except my ad blocker thing. But everything else related to this web page isn't going through. I'm not getting any responses, because the first TCP connection is stuck in this loop, and my server can't handle any other TCP connections. The solution, super easy, and it's one of the reasons why Python's required. One of the reasons the handout code is specifically how it is. We go to where we're creating our TCP server. We use the threading TCP server. Bless you. And now we're multi-threaded, which handles our concurrency issue. I'm going to restart my server. And even though I'm never closing a TCP connection, I'm going to get stuck in this well true loop forever. My page is going to load just fine. Oh, please load just fine. Let me get rid of this. Just change this to pass. I wonder if it's... The way I have this, you know what? I think I'm going to run into issues trying to break this the way I want to. I think what's happening, my speculation here, is that the browser is seeing that there's a TCP connection still open, so it's using its keep alive and trying to send the next request on the same TCP connection. Actually, we can test this. Let me just put well true right here. Then we're going to reuse that same connection. Here I probably will need my, eventually the client's going to close the connection, so I will need my if dat equals 0 right here. So let's do this. This should handle, even though I'm handling one connection per thread still, I should be able to have multiple connections. And it handles it just fine. So I'm multi-threaded, even though each client is taking up a single thread, multiple threads, because we're using WebSockets as well to handle our chat messages. So each client has at least 2 TCP connections, and that's fine because I'm just magically multi-threaded. So adding threading there, threading TCP server, the library handles it all. I kind of do and don't want you doing more multi-threading. I like having it, at least for now, just taken care of by the library, and we don't have to think about concurrency. You already did that in 220. You do that in, depending on what other courses you took. You got it in some other courses too. Yeah.
Do we have a maximum number of WebSockets we can have open?
Yes, but I don't know what that number is. There might be some limit in the class here. I doubt I'm going to find it. Some default limit. I won't be able to find it quick. But there's got to be some limit eventually, even if it's just how much your machine can handle, which with multi-threading isn't a huge number. Multi-threading is very heavy. So we should be using proper concurrency here with a thread pool and things like that. But this is easy, so we can think about other things. You have enough to worry about with homework 3 without adding that to it. So there's concurrency. Without that, so if we go back to single-threaded, let me change my example a little bit. Let me get rid of this well true right here. Now, this server is using WebSockets. So even without that well true, my WebSockets do have a well true in there. I am using a well true, so one page loads just fine, and I can send chat messages to myself, but the second page won't load. It's just gonna spin forever. It's because I'm not multi-threaded. The one thread is being used for the WebSocket in the other tab. No one else can use my site. Not really a feature we want, but something that could get through testing. Like you can, conceive of testing where you only have one tab open, you do all your testing, you deploy, and you can only have one single user. Not a good feature. So we're going to be multi-threaded. Oh my goodness, cats. Yeah.
So on these websites, once a WebSocket is open, do they just kind of? I guess because Twitch only uses WebSockets to some video data. Do they just send it to a much simpler computer or server that is dedicated to that one task?
They're gonna.
How expensive WebSockets are?
Twitch will not use. Speculating here, I don't know the internals of Twitch. Though they use WebSockets for chat only. They don't use it for sending the videos. Videos is all HTTP, and it's going to be multiple requests to get. Every time you're getting requests to buffer a little bit and things like that. But speculating the WebSocket part is they're probably not using a full thread per WebSocket. That's terribly inefficient. Once you have a very large app like that, you're not going to be able to throw enough resources at it to maintain all those connections. What they'll do is have better forms of concurrency where there's a pool of threads that can handle many, many connections. And then each thread is going to go through a loop. I'm probably butchering this explanation, but it's going to go through a loop and check each connection and say, do I have to do anything here? Do I have to do anything here? And then continuously cycle through them. And whenever one does need something, it's going to take one of the threads and say, okay, do this work over here. Let me know when you're done so I can take that thread back. And then share those threads, share a smaller number of threads for the amount of work. That's the same thing that Nginx does, by the way. We'll talk about it later in the semester. Nginx, that's their big advantage over Apache. Apache is using a thread, which I think there's some configuration you can do to make it not do this, to have it better. But it uses a thread per connection, and Nginx from the ground up does not do that. It uses a better, more efficient form of concurrency. Okay. So that's that. Let me just make sure I'm on track. Sharing variables across, I am not on track. And you'll have a situation here where you'll want to keep track of each of the WebSocket connections. So whenever you get a chat message, your task is then to broadcast that message to all WebSocket connections. Having something storing those connections, a list works just fine here, is going to be necessary because you're going to have to collect all those connections and then broadcast each one of those connections. For this, it's helpful to know, especially if you have good organization. This is one of the things that gets trickier with better organization, so I want to make sure I tell you how to do this because I don't want to discourage good organization. But when you have the connection, like when you say self.router.handleRequest, self.router is a reference to an object. It's a reference to your TCP connection, to your socket connection. Right? Why do I keep hitting? Why am I, okay, I missed my timing there, but we can take that reference and add it. Oh, you know what? I'm doing the wrong thing anyway. I think it's just self. You would normally do, because I have it set up with the router, I have to explain this a little more. Self.request. It is request.sendAll, right? Am I going crazy? So you can do, the autocomplete just didn't want to help me out with that one. You can append self.request to a data structure. You can store those and share them across connections. As long as this variable can be seen across different connections, which your multiple threads are going to share that, shared memory, you're all going to be able to see that data structure, and every thread can see all of the connections from every other thread, iterate through this data structure, and send all on everything that's in there. Formulate your frame that you're going to send, your WebSocket frame, iterate through all those connections, and connection.sendAll, connection.sendAll, connection.sendAll in your loop to send it in all those connections. To have a variable that's shared across all connections, for some reason is trickier than I think it should be in Python, meaning that I always have all kinds of bugs that I can't figure out with this one. You can try module level variables, put your WebSocket connections right here. I've often had bugs and issues with that, especially with multi-threaded. It would create multiple instances of that variable across different threads, and I don't know, it's just super buggy. The one thing that I found that works very consistently for me is creating it as a class variable. In Python, if you're used to Java, C, not C, but C++, JavaScript, a lot of different languages, you're going to expect this to be an instance variable. It is not. It is not an instance variable. To create instance variables in Python, we go in the constructor and do self.variable name equals some value, and that's an instance variable associated with the objects of this type. If you put a variable up here, these are class variables. These are associated with the class itself. This is the equivalent of a static variable in Java. These are associated with the class. So that's why when I access the variable, I need to invoke the class and then access the variable. And then in my other files, when I import this class, I can do the same thing. Class name.variable is only going to be one of them because there's only one my TCP handler class. It's only going to be one of those. So it's only going to be one instance of this variable. I hate that I use the word instance there. It's confusing. But that you'll have to do is the WebSocket connections themselves. So understanding that self is a reference to an object, and you can pass that object around in your code, like I'm passing self as an argument to handle requests here, add it to a data structure. You can work with that reference just like any other reference to an object, and pass that around your code. And if you have it as a class variable, you can access that variable across threads and across files. Okay, now let's go in. I do want to go into this class, but it shouldn't have been exactly where it was. But let's go into this class and write some tests. Any questions on that first? Like that's something every one of you will have to do on to do LO2 on homework 3. Because at that point we have to be not multi-threaded, but we have to be concurrent. And we'll end up being multi-threaded because that's the easiest thing to do in Python. Okay. All right, so let's write some tests. We want to test the WebSocket handshake. I want to do this in 2 steps because last semester I did it in 1 step and then everybody still had bugs. So let's do this in 2 steps. I'm going to take my accept and my key. I'm just going to take the ones we got from last lecture by going to Twitch, and I'm going to create these as variables. This is a string. My expected accept as a string is going to be this. My computed is going to be compute accept, given my key. And I want to assert expected accept equal computed, right? And then I'm going to make sure I'm calling this method in my main. You can comment this out for now. And get rid of this. I have to comment this out, or else I'll get an import error because I'm running it from a different directory. I don't know. I have to comment that out. And nothing happens, which is exactly what I want to happen. If I have, this is the way assert works here. If I have, say, the wrong thing here, I'll get an assertion failure that the values did not equal what they expected. And I'm just using assert, so I don't really get any useful information out of this. That's where I would run the debugger to see what my computed versus accept are. Computed and expected. I can see that trailing space is there, and that's not quite what I want. One thing I like to do with these because it can be very tricky to find some of these issues. Actually, I think this will show me. Let me try. Yeah, in the debugger, it's fine. But if some of you like to not use the debugger and you'll just print things to the screen, let me show that since I'm talking about it. And I have an extra new line character here. Actually, let me put it on my computer because this is an exact bug for this exact method that I found by writing my tests instead of just going to the browser. A lot of you, when you test your WebSocket connections, which should be part of your testing strategy, is you'll write your handshake code, open up your server, your app in the browser, go to the network tab, and if you have a 101 response, damn it. Is my server still running? No. Where did it take me? Here we go. This is too long. But you see this? I got a 101 response, so I know I'm good on WebSockets, right? This is an affirmative test. If this works, you get the 101, and you can start seeing your WebSocket stuff here. That means the browser's happy with everything, and I know that everything worked. If that doesn't happen, if anything, you get errors here, or you don't see the 101, or it says pending or something like that, you know something went wrong, but you don't know what. So it doesn't give you any clues. It just tells you, basically like Autolab, In 1.16, it either gives you a 1.0 or a 0.0. It worked perfectly, or you have something that's wrong somewhere. So that should be part of your testing. That should not be your only testing. Many of you, it's your only testing, and then you have to come to office hours to figure out what's wrong. I'm showing you a better way. There's a better way. So write your tests. One of my issues, I didn't get to that point there because I wrote a unit test like this, but one of my issue was that Computed had an extra new line character at the end. So Computed wasn't exactly what I expect. It was what I expected and a new line character because the library I was using was expecting a whole file of values with multiple lines, so it appended a new line character at the end, even though I was trying to use a single value for either base 64 or the hash, I forget what, probably base 64. That's not going to pass my test, but when I print to the screen, I'm going to print expected, print computed, right here, assertion error, and when I look at my output, when I'm just printing to the screen, I'm never going to catch that. You're going to be staring at this forever, and you're never going to notice that you have an extra new line character. But with that new line character, your headers are not what they are supposed to be. You have /n/r/n at the end of your line, and that also is going to be very hard to see, and your code is just completely wrong. But my assert catches that. My debugger catches that. My debugger is going to show me that new line character right at the end. And if you still don't want to do, for any reason, you don't want to do any of that, if you're printing to the screen, when you're doing the web stuff where every single byte matters, every single character matters, even when it's white space, encode the thing. If you're hell-bent on only print statement debugging, at least encode them, because then you can see the new line character at the end. If you're printing as a string only, all that white space is invisible. You're printing as a string, Python's going to do what it can to be human-friendly, but if you encode it first, it's just going to give you the bytes. And then you can see that character, you can see your mistake right away. And then you do all this, and you still have errors. This will happen. You come to office hours, my WebSocket ain't working. I'll say, you didn't do tests, and they'll be like, I got my tests right here. And they show me their tests, and it's passing, it's an assert, it's beautiful, and I love it, and they have a breakpoint, they ran the debugger. And I'm like, oh, crap. Well, I will definitely do everything I can to help you now, because you did what I expected. And what we find out what the issue is they're computing the right accept, byte for byte, bit for bit, is exactly what is expected. But then when they formulate the HTTP response, they're putting it all together in just a slightly wrong way that the browser isn't expecting. Maybe they have an extra new line character in their response. So for that, I like to have another helper method. Of course, you should have a compute accept, some method that takes the key and returns your accept like I have here. Hopefully, I can at least get you to do that. That's parsing out that piece of functionality to make it easier to test is going to save you a lot of time. But also going a step further, HTTP, oops, I don't have to do HTTP. If it's a request in this class, we'll assume it's HTTP. And generate my entire request. I have a generate handshake response that's going to take a request. I'm just going to pass. I'm going to use my request constructor. And where am I? I have my server here that has errors. And I'm going to go to my WebSocket request. My browser sent this WebSocket HTTP request for an upgrade to WebSockets. So I know that this is, it should be right. 99.9, 1 in a million times. This won't be right, I guess, if there's some weird bug in the browser that I hit. This is going to be a correct request, a correct upgrade request. I'm just going to paste that thing right here. I'm going to note my key, or actually I'm not going to note my key. I'm going to modify this request very carefully. Making any mistakes right here is going to be pretty detrimental. I'm going to take my key here, very carefully insert this right where the WebSocket key is, making sure I don't delete the /r, or make sure everything is exactly what I expect here. Be careful when you're modifying these requests. But put that key in there so I know what my accepts should be in the HTTP response. And then I can test my helper method that I'm doing here. And for this, I'm not going to do all the asserts and everything, because I'm just going to get one big. I don't have it set up the best way right now, but the response is going to be the string. Oh, yeah. Gotta get rid of that. I have an assertion error. So now I can look at my response, at the very least, look at your response and look through it manually. You can have some extra helper methods that parse your responses, maybe give it to your request constructor and see if it has what it's supposed to have. But going through this, at the very least, looking through your response, if office hours would go a lot smoother, really, if you go, before coming to office hours, right before you send anything to the client, print out that response. Because that's a lot of what I do in office hours. I say, oh, let's print out that response, and then I look through and say, right there, it's not the right thing. That's probably, I don't know, at least 25% of office hours are exactly that. If you at least just print out your responses, or use the debugger, of course, like this. But now we can look through this and make sure it is what we expect it to be, or do something more formal. So here's my WebSocket accept. It should be exactly what I expect here. If it's not, sometimes it's completely different than what you expect. What usually happens here in the situation, that scenario where the student has all their testing and the breakpoint and everything, but their HTTP stuff isn't working, usually what it is when they read the header containing the key, they have either extra white space at the end, the /r/n is there, or maybe just the /r, or the preceding space. In your headers, like in this request header, where are we? You have this preceding space. The protocol says, HTTP says, the space might be here, it might not. If it's there, ignore it. Header values can't start with a space. So what some of you have is split headers, split this on /r/n to isolate the header. Split on colon, everything before the colon is the name, everything after the colon is the value, without stripping out this extra space. And I say stripping because it's .strip in Python. Preceding and trailing space is removed. If you have this space in here, your computing the key might be perfect, but if you have that extra white space in there, which is a 2-0 in hex, that's a byte of data. We think of it as an empty space that shouldn't have any bearing on anything. It shouldn't affect anything. But to the computer, you have 2-0 as your first byte that you're sending, that you have as part of that byte sequence of that byte array. It's a completely different value. The SHA-1 hash is going to be 100% different. And then the base 64 encoding of that will be 100% different. So your values will be way, way off if you don't get rid of this leading white space. So having a test case that's going to do the whole HTTP thing, this can save you a ton of time as well. So you're not changing the code, randomly guessing what's wrong, going to the browser, seeing that the 101 still isn't coming in. You go to the console and it says error establishing a WebSocket connection, and you're just guessing at that point. If you even if you don't write a full test case, if you print out what your response is before sending it, then you can eyeball that. I think I would want to see a whole test case, because you're going to get, if you're just printing out your response, let me think through this a second. If you're just printing out your response, you're not going to know what the key is. So you're not going to know what the accept is supposed to be for that response. That means every time you want to check if you're sending the right accept, you're going to have to look at the key, because if you're printing out your request and then your response, you go to the request, you take the key, you take the SHA-1 hash of it, you take the base 64 encoding of that, You hope you don't make any small mistakes in any of that and any of the cut and pasting and all that. And then check to make sure it's do write accept, which is painful. If you split this into a separate method, it makes it a lot easier. Your debug cycle is seconds instead of minutes. It can significantly reduce your time. And then you can actually see what the error is a lot faster instead of just guessing. So that's what I recommend. I wanted to see these two things. You're testing your computing the accept, and then with a whole request. If you don't have either of those two things, I don't know. Don't bug me in office hours. You can't. I don't want to say it. I don't want to say it that strongly because I still want your questions in office hours. But if you don't have these two things, your question in office hours should lean towards, wait, how do I set up that testing? Can you show me the testing thing again? And I'd be absolutely happy to go through the testing thing again. But if you just show me your browser and say, how come I'm not getting 101 and you don't have any of the testing and there's no clear attempt to do testing, and I mentioned testing and you shudder and go, oh, I don't want to do testing. What am I supposed to do to help you at that point if you ignore all my advice? Yeah.
So when you added the new line at the end of the key, right, and you use that key, you append it to that 20-character string that you gave us that's always the same for every single website and WebSockets, and you send that all together as a response, as a one-on-one switch of protocols. Even if there's a new line at the end, is it still going to read it, and is it still going to send the response or no? I am not accounting for that.
With the new line at the end, so when I don't know why I deleted it while you were talking about it. If this new line is at the end of your computed, it won't read the header properly. I believe it depended on browsers, because I think some browsers treated the /n as a /r/n and just said, oh, there's an empty header. But some of it took that /n as part of the accept and said the accept is not what I expect. Therefore, this is not a valid handshake.
When I tested it in front of you, Chrome didn't see it as Firefox did.
Okay.
Same exact issue.
Okay.
That's what I was asking.
Chrome worked in Firefox then?
Chrome was having a protocol.
In Firefox then. Okay. Yeah, so that might have been the difference between those two. I think that might have been Chrome treats that as a blank header, and Firefox said /n is at the end of that line. And if you have that leading space on the key, by the way, let's take a look at this one. My expected accept and my computed accept, 100% different. Just one leading white space character completely changes everything. So we're taking a SHA-1 hash of it. If even one bit is different in the input of a SHA-1 hash, we want the output to be completely different. We don't want somebody to get really close to a guess of our password and say, whoa, the hashes were pretty close. I must be close. No, we want one bit difference, completely different output. That's what we want from these things. So we're going to get that, and we do expect that. Completely different outputs. Okay, we got to do some WebSocket frames. We haven't gotten to a frame yet. I have to fix some things because I have a screen full of errors here, which I think is just that. I have to run my server, which it's running. When you're testing WebSocket frames, I think you get the idea of testing. I'm going to grab some bytes and call some helper methods and make sure they're doing the right thing. So I'm going to try to shift gears a little bit here. Let me go back to my code. Is this working? How much did I break things? My TCP handler is not defined. Because I didn't restart it after I fixed it. That's all fine. Let's say hi in chat. Let's look at the network tab. So the network, I showed this briefly in one lecture, but once your 101 works, in messages, of course it's not showing up. Why is it not showing up? Am I filtering? Maybe I clicked the wrong thing. I don't know. But I can see all the messages that were sent. But now I refresh and they're whatever. But oh, I know because I'm preserving log. That was my old one. But you can go to this messages tab, aside from headers, go to messages, and I can see the messages that are sent and received. So it's one thing that helps debugging. I don't have much else than that to say about it. It shows you all the messages that were sent and received. But then after I send that, let me go back to my browser. And what I recommend is printing out your WebSocket frames when they come in. So I have my while true loop that's breaking on opcode 8. And in that loop, whenever I get a WebSocket frame, I'm printing it to the screen. And I like to print it in binary. I like to print it in the same way that the protocol specifies it, 8 bytes wide and in binary. So if you want to steal this code, this one I'm fine with you stealing. I'm going to convert my byte, a single byte, into binary, convert that to a string. I'm going to remove the first 2 bytes of that string, which are going to be the BX, to say that this is a binary string. I don't need to know that. I know it's binary. So I'm going to remove that. And then I have, this is kind of hacky, but it works. I'm going to add pre-penned zeros, as many as I need to make it an 8-byte string, because the leading zeros will be dropped when you convert to binary like this. The binary is going to remove those leading zeros when you convert it to a string. So I'm going to add in those leading zeros, as many as I need to get a length of 8, so then I can have it print nice and pretty. And then I have a loop that goes 4 bytes, new line, 4 bytes, new line, 4 bytes, new line, with spaces in between, to get this printed all nice and pretty the way that I expect. Then I'm also printing the bytes. The bytes of the frame are what I'm going to use in my test, which we're not going to have time for the whole test for this. Where am I? There I am. But this would be my input for my frame. I would paste that frame, just printing the raw bytes to the screen, copying that, pasting it. I know what my expected message should be, even if I don't get it from here, because I need to code all this before I can get that. But I have the message right here. I know what the message is supposed to be, and I can use that in my test case to make sure I extract the payload properly. I know what the opcode should be. It should be 1. I know what the fin bit should be. It should be 1. I know what the payload length should be. It should be 44. And I can use all that information in my test. So I can assert all that, call my code that parses a WebSocket frame, and assert that all those values are what I expect given this sequence of bytes as my frame. So I have all that information there. And with that, we got 2 minutes. We can do a little bit of this at least. I want to look at the bytes. So these bytes are the exact same bytes as these bytes. I have 8, 1 as the first 2 bytes. That's 8 and then 1. These are the same exact bytes that I received when I called receive on my TCP socket connection. Same exact bytes. And we can take a look at what these bytes are if I resize oh my goodness. If I resize things carefully. We can go to our protocol. And see what each one of these values should be. Oh, I thought I had, it was the previous lecture. I have one slide where I have it really big. There we go. I can't get rid of the sidebar, I guess. There we go. And we can look at this. The fin bit is 1. Reserve bits are 0. The opcode is 0001 because this is a text frame. The mask bit is 1, so I know that I'm going to have a 4-bit mask here. Then payload length is these 7 bits right here. I'm not going to do the math, but in binary that should be 44. We saw this is a 44-byte message. Then the next 4 bytes are going to be the mask. Since my payload length was less than 126, the payload length is only 7 bits, so I expect that to be the payload length. The next 4 bits are the masking key. None of this other payload length stuff exists because I had a 7-bit payload length. Then the masking key is the next 4 bits, and then the first bytes of my payload all the way down is my 44 bytes of payload. So this first byte is going to be 0, 1, 1, 1, 1, 0, 1, 1, which should be an open brace. If we pull up the ASCII chart and everything, we'll see that that's going to be an open brace. And then all the other values XORed with each byte of the mask all the way down. If we send a larger message, You should have time to send just one large message. What I like to do in testing is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Copy 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 100. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 1,000. Send it. I should get a very large frame. And the one thing I have time to highlight is we're going to get exactly 126 here as the payload length, which means I have a 2-byte payload length. So this is my payload length. The next 4 bytes are going to be my masking key, and then my payload, however large that payload ended up being.